train and I gotta go on to the next fantastic voyage into my father's brain. Have you seen my dad's brain around here?
According to Mark's father, with every choice and decision we make, with every event in our life that could happen in more ways than one, universes branch off in different directions. Every time we make a decision, we divide into two different versions of ourselves. This is how parallel universes. Mark is going to be shown the double slit experiment by Yi Ma, a technician at Princeton's physics department.
Like that, or you expect the photon will go all over the map. What do you expect? We have two slits here.
The choices are all over the map, or just those two spots?
Just two spots, yeah.
Yeah. Just the two spots?
Exactly. Mark is using his common sense. Imagine this experiment was blown up to a much larger scale so that the particles are tennis balls, and a machine is firing the tennis balls at a barrier with two gaps in it. Of course, you'd expect to find the balls hitting the back wall in two places, in line with the two slits. But when our experiment is done with individual photons from the laser, something very different happens.
Okay, you see the screen up there?
Yep.
That's what we see from the camera. See those individual flashes?
Oh,
there?
yeah.
Those are the photons.
Each flash of light is actually an individual photon hitting the back wall. They appear to be landing all over the place. But watch over time and a pattern emerges.
Can you see somewhere in the middle of the screen?
It looks like a smudge.
Yeah, it looks like a smudge.
Yeah.
Those are the photon, where the photon hits. But it's not two, as we would expect. Is that weird?
Yeah, so why is that?
That's right, why is that?
Instead of the two vertical bands that you'd expect, a series of vertical smudges appear. To make sense of this pattern, you need to look at it from the perspective of a single photon. This photon is landing in a place on the back wall that would be physically impossible if it were travelling straight through just one of the slits. So, the only explanation is that the particle has gone through both slits simultaneously. By the time it reaches the back wall, it has come together again as one photon. Multiply this single photon 1,000-fold, and you have the distinctive pattern that Mark saw. Think about it. A photon arrives at the slits in a hell of a quantum state and travels through both. A single object is in two places at once.
Now you're blowing my mind.
Good, that's our job to do, to blow people's mind, so make you think, right?
Whew, my brain hurts.
Okay.
I wish I was back home playing my guitar.
And it's not just photons that behave like this. The double slit experiment has been replicated with electrons and with atoms. But we are made up of atoms. So, atoms can be in two places at the same time. Why can't we? A meeting with Max Tegmark, top physicist and Hugh devotee, is set to bend Mark's brain further out of shape.
It's a real honor to get to meet you, because your dad has just been such an inspiration to me.
Oh.
When I was a grad student in Berkeley, I found in this old bookstore a copy of this 137-page paper that your dad wrote, and it was like, wow. It suddenly all made sense. And since then, I've spent many years working on your dad's theory and various implications of it, and it's just so cool for me to actually get to meet you here and to even have a chance to help you understand.
Mark's father wasn't the only one who found Bohr's theory difficult to swallow. So did the physicist Erwin Schrödinger.
As Schrödinger himself pointed out in a famous article, that there's something really weird about this idea of dividing the world into two parts. Because, you are made out of atoms. So if an atom can be in two places at once, so can you, right?
Schrödinger had devised an experiment to expose this absurdity. He came up with the most famous feline experiment in science, Schrödinger's cat. It goes like this. A cat is penned up in its steel chamber, along with a radioactive substance such as uranium, a Geiger counter attached to a quick-release hammer, and a flask of poisonous gas, hydrocyanic acid.
No.
Yeah.
He doesn't even have legs, and now you're going to poison him?
Don't blame me. Blame Schrödinger.
Schrödinger was never diabolical enough to do this for real. It was just a thought experiment. At the heart of it all is a quantum event. Every now and then, completely randomly, there's a chance of a uranium atom decaying and emitting radiation. This radiation is enough to trigger the counter that sets off the hammer, breaks the vial that poisons the cat. But if none of the uranium atoms decay over the duration of the experiments, the cat will live.
What's so disturbing about this is the fate of a single atom, right, determines the fate of a cat.
According to the Copenhagen interpretation, until the experiment is observed by peering inside, the entire contents of the box exist in two possible states. Each uranium atom both has and has not decayed, and still further, the poisonous gas has both killed and not killed the cat. And this is the paradox. A single cat that is both dead and alive at the same time. That's what Schrödinger couldn't buy, and neither could Hugh. In the winter of 1954, sometime after the Bohr lecture, fortified by some sherry and chat with Bohr's assistant, Org Peterson, Hugh came up with the theory of parallel universes. Hugh argued that everything in the universe, big and small, obeys the laws of quantum mechanics. And, instead of the observer, Hugh introduced the notion of splitting. Splitting occurs every time a quantum event happens, and this is how parallel universes are created.
How does my father's theory solve the two different outcomes of the cat experiment?
It says that both outcomes actually happen.
The paradox of Schrödinger's cat had been that the one cat was both dead and alive at the same time. Hugh solved the problem with parallel universes. Two cats existing in separate worlds, one cat dead, the other alive. Hugh's theory was visionary and backed up by some serious maths. He was only 24 years old.
Some people think you have a problem, but that problem lies only with them. Beautiful freak, beautiful freak.
In my personal opinion, your dad's theory is one of the most important discoveries of all time in science. I just can't emphasize enough how important I think it is. And so I would put it right up there with Einstein's relativity theory and Newton's theory of gravity and so on. And I think 50 years from now, he's going to be even more famous than he is now when more experiments have confirmed that this seems to be the way the world works.
I'm starting to understand a lot more now. Just need to come out here into the nice Princeton air and shake my head a little and let it all settle. Talk to the squirrels. So if one of the squirrels gets the decayed poison and the other squirrel gets the non-decayed poison, oh shit, now there's three of them. Now I'm really confused.
Here we go! Walk myself down Sycamore Street. The sun beats down, no shoes on my feet.
Don't use it.
Your dad's theory is one of the most important discoveries of all time in science. I would put it right up there with Einstein's relativity theory, Newton's theory of gravity.
There really are very large numbers of versions of you that really exist.
Now you're blowing my mind.
Good.